Good day, class. For the first couple of days of this unit, we've just been working on graphing sine and cosine. So today we're going to talk about how to kind of go in the opposite direction. So instead of being given a sine or cosine equation and us finding a lot of the properties such as amplitude, midline, period, that kind of stuff. We're going to be given some of that information, and we're going to find the actual sine or cosine equation. All right, so without further ado, all right, this problem here says to write the equation of a cosine function that has an amplitude of 4, a period of pi over 2, a horizontal shift of pi over 6 to the right, and a vertical shift of 3 up. All right, now it says a cosine function here. So the standard form of a cosine function is y is equal to a times the cosine of bx minus c all plus d. All right, so essentially we are going to have to find the a, the b, the c, and the d, and then just place them into this equation. All right, so first it gives us an amplitude of 4. All right, well, we know that the amplitude is simply the absolute value of A. So this can tell us, without really any work at all, that our A is equal to 4. All right, now technically your A could also be negative 4. So if you wanted to choose that, you could. It would not be incorrect. But why make things more complicated than need be? It's much easier to just say it's positive 4. All right, next it tells us that our period is equal to pi over 2. All right, well, we know from our work with sine and cosine the past couple of days that our period is equal to 2 pi over b. All right, so now we can just look at this little equation here and solve for b. Of course, we can cross multiply, so we get b pi is equal to 4 pi. Well, it's pretty obvious from here that b has to equal 4. All right, so now we have our A and we have our B. All right, next it tells us that our horizontal shift is pi over 6 to the right. And to the right is a very important fact here. All right, now when we were doing all of our work with sine and cosine, we didn't really call it the horizontal shift. Although when we first went over all the terminology, that is what I said it was. And I said it's also called very commonly the phase shift. All right, but we call it the start. All right, so we call this the start. All right, so, and of course to the right, all right, means that this is going to be positive because positive is to the right direction. Typically, when we do shifts to the left and right, we kind of think that it's the opposite of what we think, and it is, but because this negative is built in, it already takes care of that for us. So here we're going to say essentially that our start is equal to pi over 6, positive pi over 6, again, because it's to the right. Right? And we know from our work with sine and cosine that our start is equal to c over b. Of course, we just found our b to be 4. All right, so again, we can go ahead and cross multiply here, and we will get 6c is equal to 4 pi. So then, of course, we can divide both sides by 6. And c is equal to 4 pi over 6, but that reduces to 2 pi over 3. All right, so now all we have left is our d. All right, here it says that we have a vertical shift of up 3. Again, we don't call this a vertical shift with our terminology. All right, our vertical shift is our baseline or midline. All right, so, and of course, 3 up, all right, means that this is just a positive. All right, so here we're going to say that our baseline is equal to D, and we know that here it's just positive 3. So D is equal to 3. So now we have our A, our B, our C, and our D. So we just go ahead and plug it into our standard form of cosine up here. And our final answer is going to be y is equal to 4 times the cosine of 4x minus, of course the minus is built in here, our c is 2 pi over 3, and then that's all going to be plus 3. And voila, we are done. All right, so if you're watching this at home, if you weren't in class, I would recommend that you pause the video right here, go ahead and try to work this one out on your own, and then check your answer with what I am about to do here. All right, so again, we have an amplitude of 7. Of course, that just tells us that our A is equal to 7. All right, we have a period of 2 pi over 3, and we know that our period is equal to 2 pi over B, so that's equal to 2 pi over 3. Of course, this is obvious here that B has to equal 3 since my numerators are the same, but if you don't see that, that's fine. Just go ahead and cross multiply, and you would get 2b pi would equal 6 pi, and then you would divide both sides by 2 pi, and you would end up getting 3 anyway. All right, of course, we have a horizontal shift of pi over 4 to the left, so that's important, right? To the left means negative, so negative pi over 4. That, of course, is our start, which is c over b. Of course, our b here is just 3. So we can cross multiply again, and we will get 4c is equal to negative 3 pi. Of course, it doesn't matter which side you had the negative on here. If you would have said negative 4c is equal to 3 pi, that would work just the same, right? Because, of course, now we're going to divide by 4 here, and we will end up with c is equal to negative 3 pi over 4. All right, and finally, our vertical shift of 5 down. Of course, our vertical shift is just our baseline. So that tells us that D is equal to negative 5 because of this down piece. That is the negative direction. So again, now we have our A, our B, our C, and our D. So we can go ahead and say, again, it does say cosine. The only difference if it says sine is you write sine for your standard form. All right, so again, we have our y is equal to a times the cosine of bx minus c, all plus d. Like I said, the only difference if they were to say sine here is you would put sine. That's it. All right, so here we're going to have y is equal to 7 times the cosine of 3x. Of course, now my c is negative here, so when you subtract a negative number, that just becomes a positive. And then, of course, we have our minus 5. So there is our answer. Okay, so now we're going to kind of use some of those same strategies as far as working backwards to find an equation in this kind of real world application. All right, so the normal monthly Fahrenheit temperatures for the last 30 years in Mount Vernon, Ohio, are shown in the table below. It says month 1 is equal to January, month 2 is equal to February, month 3 is equal to March, etc. All right, so of course the average temperature in January is 15, February is 21, all the way up to December is 29. All right, so first it says, graph the points as a scatter plot on your calculator and include a picture in your Google Classroom submission. Of course, this was all part of your assignment that is due Sunday that was posted yesterday. All right, so I'll go over how to do some of this stuff with you here. All right, so we want to pull out our calculator, and I'm going to want to get my data here. So I'll try to get both of these over here. All right, so how we can put in data to do a scatter plot. First, we have to tell our calculator that we are wanting it to do a scatter plot. So we hit second y equals, and it will bring up several different stat plots here. All right. You can hit enter on one of these. If you're using the app on your phone, some of them like already brings it up and you can just do like touch screen stuff. But essentially you just want this set up the same way that you'll see it here. So we want the stat plot turned on. All right. The type, we want this first type, which is a scatter plot. We want our X list set to L1. That means that everything in our first list will be our X's and everything on our second list will be our Y's. So our Y list is L2. The mark is irrelevant. That's just what it looks like when it plots it on the graph. And color is also irrelevant. If you're using an older calculator, color won't even be an option. So it doesn't really matter a whole lot. Of course, second mode quits back out to our main screen here. All right, so now to put this data into our calculator, we go ahead and hit the Stat button. It will bring up these three menus here. We just go ahead and hit Enter on Edit, and it will bring up all of these different lists. All right. Of course, if you have stuff in there, you'll have to clear them out. All right. Be careful, though, that you don't go up to L1 and hit the delete button, or it will delete the whole L1 and you will no longer have an L1. You can, however, hit the clear button and then it would clear out that whole list when you come down. All right, so do keep that in mind. All right, so I'm going to go ahead and type in all of our data here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this might seem a little strange to you, but instead of calling December 12, I'm actually going to call it 0. All right. Um, when you think about trig stuff, the unit circle primarily, right, we always start at 0. Right. So when we start with degrees, we start at 0 degrees and we go all the way around. Of course, we say we go around to 360, but when we get to 360, we don't really call it 360. We call it 0 again, right? Same thing with radians. We start at 0. We go all the way around. We know that one full revolution is 2 pi, but 2 pi is the same as 0. All right, so if we're dealing with months, right, and we start at 0, right, that would really be December. Of course, we still want 1, 2, 3, 4. We want all of those to match up. We don't want to call January 0, and then every month would be like off and would be weird. So we can actually just call 12 and 0 the same thing. And that way 1 through 11 all stay the same months that we think of them as. All right. So now I'm going to go over here to L2 and put in all of my temperatures. So 15, 21, 34, 51, 60, 72. That should be a 60. Hit read 60. There we go. 79, 76, 69, 58, 42, and 29. Okay, so now we have all of our data in here. All right, and now that we've told the the calculator that we want it to graph these things as actual points on a graph, right? It will, but we need to make sure that our window, right, our normal window, -10 to 10 with both X's and Y's, wouldn't fit a lot of this stuff. So our X's are the months, and we have essentially from 0 to 11. Now, you don't want your window your points rather to be right on the edges of your window. So you want to give yourself a little bit of slack, right? So I'm going to go ahead and say -2 to 13. So it gives me a couple of units to either side there. Scale here of 1 is fine. All right, now my lowest Y value, my lowest temperature is 15, and my highest is 79. So you could go like 10 to 90 or I'm just going to go 0 to 100. Of course, then we don't want the y-scale to be 1, or it would look really messy. There'd be 100 different little tick marks. So you could call it 5, you could call it 10, anything like that will work. So now when we hit graph, we have this nice looking curve here. All right. So now we go back here. All right, so we've graphed the points as a scatter plot. It does say to take a screenshot. So if you do it on the Calculate 84 app on your phone, you can just take a screenshot of your phone. If you do it on a regular calculator or some other method, just take a picture with your tablet or your phone or whatever. That works just as fine. All right, so now it says, then model the temperature T as a cosine function of time using 15 as the minimum value and 79 as the maximum value. Okay, so now we are definitely going to want to find our A, B, C, and D again, okay? But it doesn't give us everything the exact same way as it did in the last couple of problems, so we have to figure a couple of things out. All right, well, the easiest way to kind of think about some of these things is to just think about a graph of sine or cosine that, kind of looks like this if you cut out a certain section of it. All right, so of course this is my baseline, which we know is my D. All right, and if I were to have like our guidelines here and here, like how we graph them, all right, we know that this guideline tells me where my maximums are, and we know that this guideline tells me where my minimums are. Okay, and it tells us, of course, what our minimum and maximums are. All right, of course, you could also just get those from the table, right? What is my minimum temperature? It's 15. What is my maximum temperature? It's 79. All right, so, well, how does my D, or my baseline, how does it relate to the maximum and minimum? Well, it's right in the middle of it, all right? And exactly in the middle of two numbers is called the average, all right? So you can easily find your D simply by taking your maximum plus your minimum and dividing that by 2. So in this case, we're going to get 79 plus 15 divided by 2, all right? And that's going to be 94 divided by 2 is going to be 47. All right, so D is equal to 47. All right, now the distance between the maximum and the baseline is the amplitude, which is the same distance between the baseline and the minimum. So there's a couple of different ways that we can find our amplitude here, all right? You can either say that our amplitude is equal to the maximum minus the minimum. Minus the minimum divided by 2, right? Because that means that the distance between here is 2 of these A's. So if you divide it by 2, then you would get your amplitude, which is also our A, right? You also could do the maximum minus the baseline, since we now know the baseline and we know the maximum. You could also do the baseline minus the minimum, since we have the baseline and we know the minimum. All right. So I'm just going to go ahead and do this because I think it's easy to remember, right? Max plus min divided by 2 and max minus min divided by 2. You just change the plus to a minus, right? So in this case, we're going to get 79 minus 15 divided by 2. All right, so that's going to give me 64. So 64 divided by 2 is 32. All right, so now all we need to find is B and C. All right, well, we know that B has to do with the period. All right, we know that the period is equal to 2 pi over B. All right, now, what is the period? Well, I'm dealing with months. How many months occur before we start over, before we get to the month that we're currently in? Well, there's 12 months in a year, so our period is 12. So we set this equal to 12. You can put it over 1 if you want and cross multiply, right? So we would go ahead and get 12b is equal to 2 pi. So then to solve for p, for b rather, you divide both sides by 12. And of course, 2 pi over 12 reduces to pi over 6. All right, so now we know that to get our c, which is the only thing we're missing now, we use our start. All right, and we know that start is equal to c over b. All right, well, we're dealing with cosine. It says to use a cosine function. Well, we know that cosine, all right, starts at the maximum or minimum depending on the a, but when we're creating our own cosine function, we're never going to intentionally make a negative. All right, so our a is positive, so our cosine is going to be starting at the maximum. All right, so where is the maximum value here? All right, well, the maximum value here, all right, is 79. They told us it was 79. All right, well, where does that occur? That occurs in the 7th month. All right, so my start is actually going to be 7. All right, so then of course that is equal to c over b. Of course our b we just found to be pi over 6. All right, well, if I'm trying to solve for c here, all I have to do is multiply both sides by pi over 6. So those will cancel, leaving me with just c. And of course, 7 times pi over 6 is simply 7 pi over 6. So there is our c. So now I have a, b, c, and d. So I can write the equation of my model, which is y is equal to 32. Whoops, don't want that. Times the cosine of bx, so pi over 6x, minus c, which is 7 pi over 6, all plus d, which is 47. So here is our model. Okay, well, let's check it, all right? Because in this, if we read up here, right, so part B here says graph your model you found in Y1 in your calculator and look at the graph. How does the model you found match the points from the scatter plot? Take a picture of your calculator screen. So again, either a picture of your calculator screen or a screenshot if you're using your TI-84 or Calculate 84 app, all right, and include it in your submission. All right. So all we have to do is go here to our y equals, and we type in this equation that we just found, which we know is 32 times the cosine. Of course, our alpha y equals enter a fraction command works best here. So pi over 6x minus, again, we'll want our fraction command here. So 7 pi over 6. All right, and then plus 47. So now we can graph this thing. That's a pretty good model. It's a little off, right? We probably would like it shifted a little bit further to the right, all right? But it's a pretty good model, all right? Matches up relatively well. So that's what you would say, right? You'd say, well, matches up pretty well here, and includes your picture, and you're done with that problem. All right, now number 4 here says, look up the average monthly temperatures of a city of your choice online. Record the temperatures in a table similar to the one in number 3. Model the temperature T as a cosine function, just as you did in the last problem. Check your model using your calculator and include a picture of your submission. Obviously, I'm not doing this for you. This is for you to do. All right, just one kind of piece of information. A lot of times when you look up average monthly temperatures of a given city, it will give you an average low and an average high. All right, so just average the low and the high together, and that's a fairly good average temperature for the whole month. All right. So that's the easiest way to do that. And then essentially you just do exactly what we did in number 3. Right? And that is all that we covered in class yesterday. So I will go ahead and stop there and make a new video for today's stuff.